Hello students. So the next topic is object location mechanism. So here we are going to learn how to locate a particular object. Suppose a processor requires a particular object file. So how will we find the particular machine where that particular object is located? So let us try to understand that. First let's go to the paragraphs. So object location is the process of mapping an object's system-oriented unique identifier, which is called UID. So basically the name that represents the object, okay, so to the replica locations of the object, okay. So the process of mapping this UID with the location is basically object locating, okay. The process is called object locating. It may be noted here that the object locating operation is different and independent of the object accessing operation. So what do you mean by that is locating a particular object is a separate activity or separate event, and accessing the particular object, maybe to do read and write operations, is a different activity, okay. They are separate. So in a distributed system, object locating is only the process of knowing the object's location, okay. So we are fully concentrating on knowing the object's location, okay. That is the node on which it is located, that is the particular computer which has the particular object, okay. On the other hand, object accessing involves the process of carrying out the desired operation. So as we learned from the previous paragraph, the object locating and object accessing are different. So here it is more elaborated. Here it says that object accessing basically means all the read and write operations that will be done. So this is different from object location or object locating. Therefore the object accessing operation starts only after the object locating operation has been done successfully, okay. So it's a step-by-step process. So object accessing activity will totally rely upon object location. That is quite obvious, because if you don't know the location of the object, how will you be able to do any read or write operation, right? So it's a sequential activity, okay. One happens after the other. So several object locating mechanisms have been processed and are being used by various distributed operating systems, okay. So there are various approaches that are carried out. These mechanisms are briefly described below. So later in the slide we are going to have a view on the different approaches that are implemented. The suitability of a particular mechanism for a distributed system depends on various factors, such as the scale of the system, how broad or wide is the network or the system, the type of UID being used. So what is the convention of keeping the names of the UIDs, okay. You will find that in one of the techniques the name itself may hold the location of the object, okay. So and then whether the system supports object migration or not. So then we will see that if object migrations are allowed, then certain type of techniques may not be used, okay, cannot be used, okay. Whether the system supports location transparency of objects and so on, okay. So we also have to see whether transparency is there or not, okay, because as a user you should not be able to know that there are certain activities going on behind, okay, inside the system, where location is searched, then the particular object is brought to your computer, right? Those things should not be known to the user, okay. So whenever we use the transparency, we mean that the user should feel as if a standalone machine is accessed. All right, so let us move forward with the examples, or rather the various types of object locating mechanisms we have. So this is the first one. It is quite simple. It is called broadcasting. The various examples are termed with alphabets like A, B, C, D, and so on. So this is the first one, which is called broadcasting, and as the name suggests, the first step will be, suppose this is a client object, okay, sorry, this is the client node, and this client wants to have an access to a particular object, okay. So how will the object be obtained? So in this particular approach, what happens is, from the client computer a message will be broadcasted to all the other machines or all the other nodes, okay. And step 2 will be a reply from the node on which the object is located, okay. So the response will only be given by the particular machine which has the particular object that was searched for. Simple enough. But of course there will be certain disadvantages as well, because if the network is very broad, okay, there are lots of machines that are connected in the network, then of course the message has to be broadcasted to a large amount of machines, right? A lot of message passing will occur, though of course the reply will only be provided by those machines which have that particular object. That is totally fine, but in the initial step we have to go for broadcasting, and whenever we all know, whenever we go for broadcasting, we have to have a lot of messages traveling through the wire, right? Then we come to the next example or next technique. The diagram looks little scary, but the concept is very simple. So we already know about hop, I believe, right? Whenever we talk about computer networks, we talk about hop. So when we go to the next particular machine, it is one hop. When we go to another, it's the next hop, and so on. Okay, whenever a packet goes from one terminal to another, basically it's a one hop. Okay, so here we have this client node, and the client node wants to have an access to a particular object. Okay, so what happens here is the client searches for the nodes at 0 distance hop. So if you consider this to be various machines we have, then we can arrange them in terms of hop. Okay, so that means in a first cycle these computers can be accessed by a single jump. Okay, this if we consider the second ring, then these particular machines can be accessed by 2 jumps. Okay, that means we have to go through one machine, then go to another, and this will continue. So in the third ring, of course, we have to go 1, then maybe 2, and then 3. Okay, so it looks like a ring now. So we have multiple rings here, and so it's expanding ring broadcast. Okay, the concept is called expanding ring broadcast. So we keep on expanding the ring. Okay, so first this particular machine is going to search for the object in the first hop, which is considered as a 0 hop. Okay, so here you can see these are ones, right? These are messages of this particular first sequence. Okay, so here you can see it's called 0 hop. So you just go to your neighbor and see whether they have it or not. If they don't have it, then you go to the next node from the neighbor. So you go to the second ring, and it goes on. So here you see it is not 3 but I. That means it can go up to any number of times, right? It depends upon how vast the particular network is. Okay, so this I can be any large number if it's a broad network. Okay, so this is very simple. So whenever this particular object is found in any of the machines in a particular ring, the whole mechanism will stop and the client will get access to the object. Okay, so let's move forward to the next one. This is very straightforward. Encoding the location of an object within is UID. So okay, so here it says that the name itself will have the location. So we already learned, or we already got to know about UID from the first slide itself. So in the UID itself, the location may be written. So extracting object's location from its UID. No message exchange with any other node is required for locating the object, right? Because it is very straightforward. Okay, you just look at the name and you find the location of the particular object. All right, but in these cases we have to discard migration of processes. Okay, we have to discard migration of even resources. Why? Because since the location is mentioned in the UID itself, we always have access to the object as long as it is held by that particular machine. So if this particular object goes to some other machine, then when the client want to access it, it will not find it. Okay, there will be no responses. Okay, however, it can be tackled. This type of scenarios can be improvised. We are going to learn that afterwards, but here the problem is we cannot support migration. Okay, if we have to keep the name, if we have to keep the location in the name itself. Okay, so if you look backwards in the previous example also, there can be demerits. Suppose the object is located at the last ring. If you consider these rings, if we have to suppose the object is at the last ring, then we have to go for maximum amount of message passing until we find a particular object. Okay, but if we had used the next technique, suppose we had used this technique here, then we would not have to go through all these rings. We would have directly gone to the particular machine and access the object. However, we are not doing that. We are going wandering after another in order to find the object. So there is a demerit here. So as we have seen, each of the examples have their own demerits. Okay, here the demerit is we may have to exhaustively search for the object, and here the demerit is we cannot go for migration. Then we come to the next example, and the next technique, that is searching the creator's node first, then broadcasting. So here it's like a mixture of earlier concepts. So here number one is searching the creator node. So this client, when requires an object, is directly going to talk with the creator of the node. So there must be a registry where this information is there, or maybe we will go for the previous concept where the location was mentioned in the UID. So the client is directly going to talk to the creator and ask for the particular object, but if not found, that is, if you look at the number 2 step, if a negative reply comes, then this client is going to broadcast request message, something that we learned in the first technique itself. So if not found, then we are going to broadcast it, and then reply will come from the particular machine which has the particular object. All right. Then we move forward. Here we are going to use pointers. By pointers we mean we are going to keep location of the next machine where the object is placed if there was a migration. So what it means is using forward location pointers. So 1, 2, 3 path of message forwarding. So what happens is this client requires an object and is going to talk with the creator. Now if the creator had migrated the object to someone else, that's totally fine, because now the creator will say that okay, you have to search to some other machines, I don't have it, okay, something like this. So 1, then creator says I don't have it, but I know the next machine where the object was passed, so you go to the next machine, and then this machine, if it doesn't have it, then we'll say okay, go to the next machine. So finally the particular machine will be found where the object is located, and that particular machine is going to reply back the particular acknowledgement saying that yes, I have the object. Okay, so it is like a pointer. However, you cannot have pointers in a distributed environment. Here pointers basically means the location of the next machine where the object was passed, okay, or forwarded. Okay, so the next topic is using hint, catch, and broadcasting. So here we have 3 steps. Number 1, searching of local cache, then broadcasting request messages, and reply will come from the node which has the particular object. Okay, so as the diagram signifies, step number one is inside the client node itself. So what it means is, first the client machine is going to access the local cache and see if it has the particular UID and respective location as well. Okay, so every machine is going to do their best to keep the registry of various UIDs and the locations. If found, then very good, it will directly access that particular computer or node and try to get back the object. Otherwise it is going to go for broadcasting. Okay, so 1 it was inside the machine, 2 was a broadcast, and 3 is the machine which has that particular object. So it's a reply from that particular object saying that yes, you can take it from me. Okay, so these are various techniques that we studied. So this is the end of the slide. I hope you found it very informative as well as very easy to grasp as well. I hope you found the concepts to be very simple and straightforward. So with this I would like to wind up this concept on object location mechanism. We will again meet in the next video. Thank you.